Hello, everyone. Good to have you all online today to introduce the database contest of Huawei Developer Competition. My colleague Davish and I will work together to get you on how to build application solutions by leveraging Huawei Cloud Database Services. I will talk about GaussDB for OpenGauss, our database service. Davish will talk about two database tools, DRS and Hugo. Before I start my presentation, a short introduction about myself. My name is Tony, in charge of database ecosystem and Huawei Cloud Database team, experienced in developer relationship and community management. Now let's move to the database contest. As part of Huawei developer competition, if you are going to join this database contest, you should learn our database service, GaussDB for OpenGauss. As our flagship database service and Huawei Cloud, GaussDB for OpenGauss is a distributed database built on the OpenGauss ecosystem, serving the enterprise customers through public and hybrid cloud. In this contest, we encourage you to build tools or solutions by leveraging the open capabilities of GaussDB, database and application migration service, named as Hugo, and data replication service, short for DRS. Your project could be tools or solutions for database migration, backup, disaster recovery, database management, intelligent operation, and so on and so forth. The contest is open. We didn't set any limitations here. So how do we judge the submissions? The basic requirement is your submission must use at least one of these three key services, GaussDB for OpenGauss, DRS, and Hugo. Then we will review from technical architecture, functionality, creativity, and business values. The proportion of technical architecture and creativity is 30% for each. Functionality and business value is 20% for each. For technical architecture, we will measure the integration with Huawei Cloud Services and how the services power your project, the stability and security. Functionality. Core function of your project should work logically and with good user experience. Creativity. We will measure the innovation and new features of the project. Business value. Is there a clear market or target audience? The benefits for investors and adopters. Are the marketing plan and required resource reasonable and executable? So let's talk about the Huawei strategy and database area. Huawei continues to invest and drive the innovations in database from these three strategic levels: software and hardware integration, investment in basic research, and open ecosystem. As you know, Huawei has long-term experience and leading advantages of software and hardware. This gives GaussDB the unique strength to build all scenario database services to cover OLTP, OLAP, NoSQL, and related tools. Today, more than 1,000 database experts gathered in 7 global research centers worldwide to accumulate leading technical capabilities. And Huawei Cloud, we embrace the open source ecosystem such as MySQL, also contributed GaussDB kernel to the community, collaborate with the whole industry to build an open Gauss ecosystem. So next, let me introduce the architecture of GaussDB. GaussDB is an enterprise distributed database built on the OpenGauss, combines the enterprise-grade performance of traditional databases together with the high scalability and availability of distributed database. GaussDB is the right choice for core transaction businesses in career, finance, electricity, government, and public safety industry. Why? Compared to traditional database, GaussDB has 5 advantages. High availability. The RPO of intercity equals to 0, and RTO is less than 60 seconds. The RPO of remote is less than 10, and the RTO is shorter than 10 minutes. High performance. GaussDB can support a business with an average of 100,000 transactions per day, but still keep high throughput transactions and ensure the strong consistency. High scalability. No need to shut down the database services. GaussDB can support on-demand horizontal scaling of capacity up to more than 1,000 nodes with linear expansion ratio. High security. GaussDB has the industry-leading end-to-end encryption technology to ensure the data privacy and security for data transmission, capture, and compute and storage. Ecosystem tools. Huawei Cloud provides UGO and DRS for the customers to evaluate and convert heterogeneous databases to GaussDB, which David will talk about after my session. So next, let's take a look at the cool features of GaussDB. So this chart shows the GaussDB distributed architecture and the roles on the management plane. The distributed execution framework generates an optimal execution plan based on service SQL statements and uses technologies such as operator pushdown and parallel execution to improve the efficiency. First, it is shared nothing architecture. Consists of multiple logical nodes that are independent and do not share system resources such as CPU, memory, and storage. In such a system architecture, service data is stored on multi-computer nodes, and data query tasks are pushed to the location where the data is located for execution. Through coordination of the coordinator nodes, large-scale data processing is done in parallel with faster response to data processing. Second, the scenarios where data integration between DNs is required, such as cross-node distributed execution and associated query. The CN delivers the execution plan to the DNs, and the DN use the streaming operator to aggregate data. The third, SQL statements such as DDL and DML can be executed concurrently between nodes. It also supports the parallel query based on the data pages within a node. So GaussDB supports financial-grade high availability and full-scale disaster recovery to ensure the business continuity when facing the natural disasters or misoperations. The distributed architecture, full and incremental backup, and cross-AG or region disaster recovery technologies can achieve ultimate RTO, multi-layer and all-scenario disaster recovery capabilities ensure the security of customer data. Let's deep into these 3 key technologies. Learn how GaussDB can achieve high availability. So this chart illustrates the 3 AZ, deployment architecture. In the routing layer, 3 CN nodes IP addresses are provided for external systems. The service is deployed in a dual-AZ mode. Applications use CN node IP to connect to GaussDB for reads and writes. Failover between CNs and capture and data nodes is done inside GaussDB. GaussDB also balances the load of read and write requests, dynamically expands capacity based on service pressure, and is transparent to services. Different logic units are configured to access nearby data at the application layer, achieve real-time failover. The second feature of high availability, parallel playback and multi-layer redundancy. Through log pipelines, batch playback, and block-level physical parallel recovery, these key technologies, GaussDB greatly improves log playback efficiency, ensures the database high availability even under heavy workloads. Meanwhile, the system can detect and recover from faults by leveraging the redundancy of hardware, instance, and data, ensure zero single points of failure. The last feature of HA, full and incremental backups. GaussDB supports full and incremental backups, and the customers can also customize backup policies according to their business needs. With point-in-time recovery and flashback, these enterprise capabilities, GaussDB can achieve on-demand data rollback and recovery in any time point, and know the recovery task status. The secret of stellar performance with GaussDB, the distributed parallel execution framework. As mentioned in previous slides, the distributed execution framework can generate optimal execution plan based on SQL statements and improves execution efficiency by leveraging the technicals like operator pushdown and parallel execution. The below chart shows how this framework works. So step 1, application 1 sends SQL statements to the coordinator node 1. Step 2, coordinator node 1 use a database optimizer to generate an execution plan, and data nodes process the data accordingly. Step 3, GaussDB transfers data between data nodes through 3 types of streams: broadcast, gather, and redistribution. Step 4, data nodes return result sets to coordinator 1. The last step, coordinator summarizes and sends the result back to the application. So this is the whole process of the framework flow. The second secret of high performance, GTM, Global Transaction Manager. So distributed transaction processing. GTM-lite technology can ensure strong global consistency and offers high-performance transaction processing at the same time. Eliminates the performance bottlenecks within single GTM. The third secret, NUMA Aware. Based on the advantages of Kunpeng's multi-core CPU architecture, NUMA core binding and NUMA partitioning restrictions are performed for global data structures to reduce cross-core processing and inter-core conflicts, and improve the concurrent service processing capability. Fully utilize the native and atomic LSE instructions of Kunpeng to implement NUMA-aware spin lock, greatly reduce the number of instructions, improve instruction and data efficiency. GaussDB supports online scale-out. In the OLTP scenario, the database needs to be expanded as the data volume increases. GaussDB supports online scale-out to ensure no interruption to customer service in the process. Supports linear capacity expansion of more than 1,000 nodes. The principle of online capacity expansion is to migrate the data of multi-local tables in a cluster between different node groups. For each table that is redistributed, data expansion can be divided into 3 steps. First, baseline data expansion redistribution. Second, incremental data redistribution. Third, table switch over. The second step is critical. In this step, the row-level incremental marking technology is used to compensate for concurrent online insert, delete, and update operation in step 1. Based on the foregoing, hash bucket storage can be used to further reduce the amount of data scanned and migrated during data redistribution and the scale of data reconstruction. This shortens the overall redistribution process time and reduces the time window that affects online services, achieving rapid capacity expansion. So that's all about our GaussDB. Here, we listed some useful links for you, including our product portal, helper center, SDK, developer guide, API reference, application development guide, and also with some best practices. So you can learn more details about our product and also learn how customers are using our product in their real business environment. So I finished my part. Next, I will hand over to Devish. Hey, Devish, hand over to you.
Thanks, Tony. Thanks for giving me the opportunity to discuss the Huawei Cloud Database and multiple offerings. So myself, Devesh, working in Huawei from last 6 years, and I have an experience in multiple cloud database technologies, and I have 18 plus years in various Java related technologies and performance and scalable systems, solutioning and designing. So here now we'll talk about Huawei Cloud Database offerings, which helps customers to migrate their applications. Okay, so here we are, Cloud Database Migration Solution. It's a complete solution stack which Huawei provides for schema migration and the database data migration service. So syntax migration is a very important offering from Ugo, which helps customers to do conversion of the different database syntax and helps customers to migrate their applications from various commercial databases. Their database can be on premise and or they can be running in cloud. Oracle or MySQL or various other commercial database. So Ugo is a syntax migration tool. It is running in Huawei Cloud as a service. DRS is a data replication service which helps customers to replicate or move the data from one database to another database. The DRS also provides to verify their incremental data in real time. This helps customers to verify if any data loss or if all is good. Um, the traffic replay is another stack which helps customers to do real-time conversion and using the traffic capture of the SQL. It helps customers to do some analytical operations, helps customers to identify any useful information out of the SQL, and Huawei provides cloud databases offering like RDS for MySQL, RDS for Gauss, and it also provides a data admin service which helps customers to do the real-time database performance diagnosis and do some intelligent optimization. So it provides the real-time analysis, SQL diagnosis, and identify if any slow query is there which is creating problem or some sensitive data protection. So we will talk about the DRS and UGO in detail. Let's move on to the next slide. UGO is a very important offering from Huawei. It is a professional tool for migrating the heterogeneous data objects and applications running on commercial databases. Ugo has different stages like pre-migration evaluation and schema migration, which helps customers to do the syntax conversion evaluation and then do the actual schema migration. So let's say the customer have Oracle as a source database and they want to migrate to MySQL or Postgres or OpenGauss, Gauss DB from Huawei. They can easily do using Ugo. And the source database supports various versions. In Oracle, Ugo supports 11, 12, and different versions. RDS for MySQL, RDS for Postgres, these are all the target database which customer can migrate their applications over Huawei Cloud. So Huawei also have achieved the CAICT certification, which is a very reliable and very important certification awarded to Go as a product in terms of usability and efficiency. Now talking about the stages in Ugo, we have database schema migration. So let's say the customer is having a source database. So we have Ugo where Ugo fetches collects the data and schema and all the database objects from the source database. And after collecting all the database objects, Ugo run the pre-migration and do the evaluation. How the source database objects are compatible with various target DB, and it prepares a report to help customer identify if any syntax conversion support is not there, or if source database is having is for source database is having any incompatibility issue. So pre-migration evaluation is a step to do the migration, schema migration before the actual migration, and after pre-migration, here the customer can do the object filtering. An object like packages, procedures, user objects, and all the different objects in the database. User can do the object filtering, that which particular object user want to do the schema or syntax conversion, or if user don't want to do any object filtering, it will do by default all the objects syntax conversion. During syntax conversion phase, user can configure a lot of configurations supported by the target database, and to support the maximum conversion ratio, so that if user have 100 syntax objects, and from migration of the source database to a target database, if a customer wants to have 100% syntax conversion, so he can configure some database configuration properties on the target database, and then the syntax conversion can be run. Syntax conversion will actually run in real time, and once the syntax conversion happens, it Ugo shows how the conversion ratio, and if any syntax conversion is failing during the syntax conversion step, then user can do the manual object correction of the syntax, and then it can rerun the syntax conversion step. So it can pass, so it will increase the conversion ratio, and again if it fails, then again user can do the syntax conversion correction, and then the verification of the syntax will happen in the database, target database, and it will be verified for actual completion of the migration into the target database. So it's an iterative process which actually helps customers to correct the syntax manually if any syntax conversion fails, and then do the actual verification into the target database. So let's talk about the database evaluation project. Ugo helps customer to create a task, a evaluation project, which actually collects the source database information, performance data, and SQL statements of different object types like procedures, packages, users, and then Ugo generates a source database profile, and it evaluates the syntax compatibility between the source and target database based on the data being collected from the source database. And then Ugo have a very important feature, like Ugo intelligently identifies the collected data from the source database, and it recommends that user can select which type of target database to get the maximum conversion ratio, and it also estimates the how much migration workload for each of the target database, and it also identifies the migration risks based on compatibility, performance, and if there are some objects which are very, very complex, very big, like packages and stored procedures, it also gives the idea to the customer that how much will be the workload, and if any risks in having conversion, and if any syntax conversion will fail. So Ugo have intelligently recommends different types of target database with specifications, and helps customer to achieve the highest conversion ratio for a given target database in cloud. So you can see that evaluation project is a task which tells to customer that how many evaluation project or task the customer has created. It is a dashboard which helps customer to give an idea that if he has two different source databases, he can create two different evaluation projects, and they can run independently. And the migration also is one of the tasks. After pre-migration, user can create different migration project for different target DB, and on dashboard it gives the progress of each of the tasks. So let's talk about the migration project, which is actual migration of the source database syntax. So customers select the evaluation task, which is to be migrated, and it ensures that Ugo can connect to the target database. And this all happens in real time. So there is no downtime involved in the source database or the target database. And based on the migration risk report generated by Ugo, user can configure a migration solution, which is actually a migration tasks. And then Ugo converts the SQL statements of the source database to the selected target database. And finally, the converted SQL statements are verified and they actually being applied in the target database. So they actually being run in the target database, which completes the overall migration process. So migration process is a multiple step process where a conversion plan is created, then conversion configuration by the user on the target database, then the syntax conversion happens, and if any SQL object conversion fails, then customer can manually correct the SQL syntax and can rerun the migration. So once the object correction happens manually, then user have option to manually rerun the migration again only for the modified or corrected SQL syntax. So this way customer can complete the all the steps of migration, and all the SQL statements will be migrated to the target database. So you can see that we have multiple steps here: a conversion plan, then conversion config, then syntax conversion, then if any manual object correction, and this is the final step of migration and verifying into the target database. Okay, so this completes the Ugo product offering as a schema migration tool, and it's an Huawei cloud. This is one of the very important thing for schema migration. Now we talk about another offering from Huawei. It's also available in Huawei Cloud. It's a data replication service. So once the schema is migrated for the customer application, then customer also need to replicate their data into the target database. So it's a DRS which actually helps customer to do the online data transfer and the real-time synchronization of the data from source database to the target database. So DRS is a very stable, efficient, and easy to use cloud service for database online migration, and it's a real-time synchronization. There is no downtime involved in this. Customer can easily replicate or transfer the data from source database to the target database, and it reduces the data transfer costs, and it also simplifies the whole process. We will talk about it, how it is. So you can see that DRS address customer pain points here, and the cloud database architecture is very advanced and cost effective. But some customers worry that migration of the data may affect their services because there may be a downtime of the source and the target database. Then they worry about their business, and it actually continue to worry them about their increased cost and the demand of the data. So customers don't have sometimes the technical knowledge that how they can handle the database issues during migration, and if any data loss is there, then it will be a very unhappy customer. So customers are not satisfied with the state of their services, and there is so much concern about the service performance after migration. So these are the very general and the very important pain points which DRS addresses, and DRS supports different cloud vendors, including Huawei, its own cloud platform, and it also supports on-premise database to have the data replication and it can also do the data migration in Huawei's cloud platform, which is GaussDB or RDS, Relational Database Service for MySQL or for GaussDB. So customers can replicate their data from on-premise database after schema migration and use the DRS to move their data over the Huawei Cloud Platform database like RDS or GaussDB. So, how DRS is addressing the pain points that the DRS never bring the source database down. So it actually provides a service continuity for customer, and DRS makes the migration simple because DRS automatically identifies the problem, and it also recommends different actions, which makes the migration simple and easy. So DRS addressing customer problems, so customer can predict how the service performance before the actual migration, because DRS allows customers to do the trial run before the actual migration or application of data, and which helps building customer confidence. This is a very important and unique in the industry in terms of Huawei's product offering. Now talk about the internal process. So you can see that DRS is a two-stage process, and the other services which may be doing the downtime, but DRS don't actually do the downtime of the source database. So it's a two-stage process where actually the source database will continue to run. So it's one stage is the full migration of the data. Then the second stage is the incremental synchronization of the data, which is left out during full migration. And this can continue to synchronize till customer stops over and say, okay, I have my whole data has been migrated now. So continuous services so we will talk about in detail in incremental synchronization what happens that the source database generates the log files, and DRS captures and read those log files, and after the full synchronization is complete, the incremental synchronization, how it do that, it replay all the operations which is captured in the capture logs of the source database, and it continues to replay all these captured logs, and the synchronization of the data will continue till the complete synchronization of the data is complete. So we will talk about the detail how internally it's a technology and how it is important the product offering. DRS is being used by a lot of international market players, and you can see that it is used by 2,000 plus commercial enterprises, and this is very efficient in terms of synchronization, because synchronization happens in seconds, and it also very efficiently identifies the problem and helps customer in data loss problems. Okay, and it's no downtime here. So now talk about that the general architecture and deployment, how the DRS fits in Huawei Cloud, and the overall migration of the customer to database. So the source database could be on the on-premise from the customer side, or it may be on any external cloud provider. So databases on other clouds, if they are on other clouds, then it can be a direct or a VPN connection on to the Huawei Cloud DRS service. So you can see that to configure the DRS, we will have a VPC. Inside VPC, we will have a DRS running, and then DRS uses this database as a target to migrate or replicate the whole data of the source database to this Huawei Cloud database. Um, So you can see that Huawei is supporting various cloud databases like GaussDB, or it also supports the various RDS for MySQL and GaussDB, and it also supports different type of database middleware, or it a NoSQL database like MongoDB. So it's a document database service from the Huawei, which actually helps connect to various NoSQL database, and the data can be replicated to the data warehouse as well, where this data can be used as can be used for various analytical purposes, and the customer data continuous data streaming can happen to the data warehouse. So customer can use the DWS, the data warehouse service on Huawei Cloud. It also supports Elasticsearch and technologies like Kafka. So if continuous streaming of the data needs to be moved to a messaging queue, so it can actually the customer can use the Kafka as a messaging service in Huawei Cloud, and it can do a lot of streaming services. So this is the this is the overall fitment in the Huawei Cloud on DRS side. Now we'll talk about various migration capabilities from DRS. So we can see that the customer can have the source database on MySQL or Postgres or MongoDB or SQL Server. So from MySQL to MySQL, it can happen, or from Postgres to Postgres, or from GaussDB to GaussDB. So homogeneous, where source database type and target database type is same. DRS also supports the heterogeneous data migration. Like if on Oracle is a source, then customer can use RDS over cloud in Huawei Cloud as a target database, or GaussDB or PostgreSQL. So from Oracle to MySQL, or Oracle to GaussDB, and Oracle to Postgres, different heterogeneous databases migration is supported by DRS. So the very important offering from DRS is that it also supports importing the data to the data warehouse and lake. So the customer can set the data streaming pipeline where the data from the source database can be set as a streaming pipeline to data warehouse service, or a Kafka, or any other source database. So this is a very important offering from Huawei Cloud in terms of DRS. So let's talk about the DRS technical principles. So it's a very important technology being used as a two-stage process. So DRS supports full synchronization first in the first stage, and the source database is synchronized to the destination database all at once. And there is no downtime involved in this, and tables, structures, indexes, unique keys, and primary keys all can be synchronized. Okay, and DRS uses a very important technology. Like DRS first uses the sharding of the tables, and over a period of time, in a very concurrent fashion, DRS synchronizes the data without any downtime from source database to target database. So we'll talk about that, how the how this is achieved. And once the full synchronization is done, then the second stage is the incremental migration or incremental synchronization, where the log files from the source database will be captured, and using these captured logs, this is being converted to some DRS memory storage format, and then the DRS reconstruct this storage format back to replay the data in the form of SQL statements, and then those SQL statements will be replayed back to the target database. So this is a continuous process, which is incremental synchronization from the source database to the target database, which continuously keeps on happening. And any issues or any data loss, they will be identified and being reported, and it actually reduces the data loss, and very efficient and very quick. So let's talk about that how the full synchronization of the data flow internally happens. So what happens here? Let's say you have a source database, and DRS uses a technology like it shards all the tables data in multiple it multiple shards. It do the sharding of the tables, and so let's say one table is being sharded in multiple shards here, then table 2 data also being sharded. So these shards are unsynchronized, and the data, these shards are being put into a shard list, and this shard list is being read by read threads, and this group is actually reading all the shards one by one, and individual thread or a task is taking a shard one by one, and then it puts all this sharded data into a data queue. So this is all a very efficient process and very concurrent and very fast. So this happens that once the data queue is being fed with all this shard data, then this is another group, which is another tasks. It spawns the task of various write threads, and write threads or write tasks will individually take each of the data buffer, and then start writing asynchronously to the destination database. So you can see that this is all very decoupled architecture, and there is no synchronous or a coupled architecture. It is all very asynchronous, and multiple threads are there, which actually involves in sharding and then writing all the shards to the destination database. So this is the full synchronization of the data flow. Let's talk about how the incremental, which is the second stage of our whole DRS flow. Here you can see that what happens that once the full synchronization happens, that then the incremental data will be actually again so all the full synchronization of the data happened. Now we have a tracking where actually the full synchronization happened. Now the incremental data will be read into the memory and being put into incremental queue. So this queue is again incremental data, which is maybe some records in the table, in multiple tables, and then this DRS is having a very efficient technology, and which is being used in terms of identifying any conflict. Parallel analysis engine is DRS uses this parallel analysis engine. So what this parallel analysis engine do, that it reads and get the data from the incremental queue, and it checks if any data is having any conflict. So conflict in the sense, so let's say you have data from two different tables, and these two tables are related to each other. One is they are bind with a primary key and a foreign key, and some set of records are inserting the data, and some set of records are updating the same record of with the same primary key and foreign key value. So if the insert is happening, then the update cannot happen at the same time. Okay, so the parallel analysis engine is having a very efficient algorithm. It actually checks the data from the incremental queue, and then if no conflict, such no conflict is there, then it writes into a transaction queue. So transaction queue is having multiple threads, which actually replay that insert or any other SQL statements or any SQL data, it replays back into the destination database that will be having without any conflict. And if any conflict is there, then parallel analysis engine writes into a conflict queue. And once the data without any conflict is being completed, so then DRS read the conflict queue and tries to re-execute or replay this conflict queue data. And then again, if parallel analysis engine identifies any conflict, then it asks to wait in the conflict queue and not process into the transaction queue. It's a very, very important and efficient technology which DRS uses to continuously keep on incrementing synchronization of the data and without any data loss. So it actually concurrently writes the data to the destination database. So it's very fast and very efficient, and there won't be any conflict or downtime here. And it's a very incremental synchronization. Okay, so now this is a iterative process which continuously keeps happening based on the SQL logs captured from the source database. Now this is continuously keep happening till all the synchronization of the database is over. Now let's talk about the important algorithm which is being RS, and many open source database also use this algorithm to efficiently verify the correctness of the data between the source database to the target database. Okay, so you can this is a very important algorithm. How it works, that let's say you have a source data which can be represented in the tree structure. So let's say you have root node where actually you have which you have a data in one table, and then multiple nodes are there, like children nodes here, where this table data is also being referred by multiple child tables. So it's a representation of data in the source database, and a similar representation can be done in the target database once the incremental synchronization is over. Now this is the verification part, and the algorithm, what it do that it checks if the source database in the source database the root node hash and in the target database the root node hash value is same. Then it means that the all the data in these child nodes in the source database and all the data nodes in the target database, there is no change in data, and it cannot it is perfectly fine without any data loss. If the root node hash in the source database and the target database is not same, then it keeps checking down the child nodes, and it identifies that which child node is having a change in the data between the source tree and the target tree. So that's the conflict where actually there is some inconsistency in the data during the incremental synchronization, and using this algorithm, DRS identifies the inconsistent row. So then the process will be repeated for synchronizing the data from the source database to the target database to make it consistent. And this helps customers to make sure that data loss will be minimized, and they are happy customers. So this is a very efficient algorithm used by DRS, and now we will talk about the open capabilities. You can say that it is a very high level that Ugo supports the SQL conversion, which automatically converts the SQL statements between the source and the destination database. And this is the evaluation project phase, which creates the project and then project details and confirm the target database. Then this is the actual migration, or the syntax conversion happens in from source database to the target database. And then we have this completes the overall steps of the schema migration in Ugo. And DRS also have a similar capabilities, like it provides APIs for querying different quotas, like how many database objects are migrated, how any data loss is there. It also provides very APIs for analytical tasks. It actually creates a task for pre-check and trial run. It provides API for stopping the task or any comparison if customer wants to do between the source and the target database for data which is being migrated or incremental synchronization. And it also provides the real-time synchronization management where there is no downtime and customers keep track of how much data is being synchronized, if any data loss is there. So all these APIs are being exposed and customer can efficiently and identifies how the system is performing in terms of data migration. And it also provides some disaster recovery management where actually if during migration of the data from source to the target database, if any the TRS service goes down or if any actually customer wants to make sure that there is no such incident happens, then it provides the various checkpoints. So let's say you have some network connection issue happens while the actual data migration is happening, then checkpoint will know that till how many tables or how much data is being synchronized. So that checkpoint can be now resumed in a different node, which can be a primary standby cluster, and then the migration of the data will start from the checkpoint. So instead of running the whole migration again. So these are the disaster recovery management techniques provided by TRS. Some links. Welcome to go through. Thank you. So this concludes the overall product offerings from Huawei. Any questions, please continue. Thank you.